Okay, now, so for question 4, we are given a graph of f, which has 3 segments. And for part A, it asks us to find the value or state that it does not exist for each of g of -1, g prime of -1, and g double prime of -1. So let's first find part 1 of A, which is g of 1. So we have g of 1, -1, is equal to the integral of x -4 f of t dt. So then we just plug in -1 to x. And since we don't really know what f of t is, let's look into our graph. So here we have to find -1, it's down here, and then -4. And we see this is the shape of a trapezoid. So we want to find the area of this. So then one of our sides from here is going to be 2. This side distance is going to be 3. And then this height is also going to be 3. So now with this information, we now need to remember what the area of a trapezoid is. And there is 1/2 base 1 plus base 2 times the height. So then we see here that the height would be 3, our base 1 is 2, and our base 2 is 3. Now you just plug it in. Base 1, 2 plus 3 is 5, times the height is 3. So then that will leave us to 15 over 2, sorry. But because it's -1, and it's upside down under the x-axis, it's going to be -15 over 2. So now doing g prime of -1, we see that the derivative of g would be f of x. So then we'll have g derivative g -1 will equal f of -1. And so then we see in our graph, we have a point -1, -2. This point, we'll have that would equal -2. So now let's look at g double prime of -1. If we already knew that g prime of x equals f of x, then that would mean that g double prime of x will equal f prime of x. But since we're looking at g double prime of -1, we'll look at f prime of -1. So then, if we go back to our graph, to our picture, we see that here was the derivative of g of x. The derivative of g of x of -1. But since there are 2 lines here, and it's a pointing place, that means it's non-differentiable. That technically means that it does not exist. So g of double prime of -1 equals f prime of -1. This does not exist. Okay, so now part B wants us to find the function of each point of inflection of the graph of g on the open interval. -4 is less than x is less than 3, and they want us to explain. So let's recall g of x is equal to integral -4 to x of f of t. So let's just think about it. If we want to find a point of inflection, that's going to be where the second derivative of g equals 0. Well, in part A, we figured out that the second derivative of g is like the derivative of x. Of f, sorry. So if we look at this equation as increasing and decreasing, we see that it increases from -4 to 1 and starts decreasing from 1 to 2 after 1. So it would make sense that f of x is equal to 0 when x is equal to 1. So it would be increasing, 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 decreasing, decreasing. So then x will equal 1. Okay, so now let's move on to part C. So now we're introducing a function h. I wanted to find h as an integral from x to 3 of f of t. So the same function we kind of been working with. And it asks us to find all x values on a closed interval, -4, less than equal to x and less than equal to 3, for h of x is equal to 0. So like earlier, I can't actually take the integral if I don't really know the function. So we can use the idea of indefinite integral function. So I know that I want this integral to be 0. I have to have an area above and below the x-axis. So let's start by defining a couple areas in our function. So I see 1, 2, 3, 4, 5. This triangle, this triangle, this triangle, half a triangle, and this triangle. So in this one, we know that it's 15 halves. So now look at this little triangle right here. Its height is 2, and well, it's -2, and its base is going to be 1. So if we recall, the area of the triangle is 1/2 base times height, which would be 1. But it would be -1 because it is below the x-axis. So I find a similar area for each of these 4 triangles. So then each of these bases would have 1, and they have a shared height of 2. So that gives each of those half triangles a +1. And then this little triangle, again, has a height of 2 and a base of 1. But it will be -1 because it's under the x-axis. So now let's look at our integral. So now we're going from x to 3. So right here, it would have to be right here. 1, 2, 3. So let's see when these areas are going to add up. So you have -1, and when I add 1, I get 0. So then right here, my x would equal 1. So then that's going to be one of my values. So then I have 0 here, and I add 1 to get 1, and I subtract 1, where I'm then back to 0. So then it's going to be another -1. Okay, so now what if we plug in 3 to here? So now if we do that, you would have the integral of 3 to 3 and f of 3 dt. But if you plug in f of 3 minus f of 3, in the end you would get 0 because it technically did not move. So then you have 3 points of x, which is 1, -1, and 3. So those are all the values on the closed interval for which h of x will equal to 0. Okay, so now for part D, it says, for the function h defined in part C, find all intervals on which h is decreasing. And then you just explain why. So h is the integral of x to 3 of f of t. So we've seen before that g prime of x is negative x or negative f of x or f prime of x, but with h it would be h prime will equal negative f of x. And so then the x value between 0 and 2, it's going to be decreasing because since the h is negative. So because it's negative, the value between x and 2 is decreasing. And that is the interval 0 to 2.